front of you that says CP Chemistry Unit Stoichiometry. And from here, I want you to hit pause and read through this first page that talks about making cookies and what stoichiometry is. Now that you've read that, this says, as we saw in the cookie example, either the limiting reagent or the target amount of product can determine all other amounts consumed and produced. Formula weight conversion factors and mole-to-mole ratios can be strung together as long as you are careful to label every factor and arrange properly so units cancel. So back to our example, but this time we're going to start from scratch with moles. So it says we take 3 moles of aluminum and 3 moles of copper 2 chloride, and we make copper and aluminum chloride. So from these initial 2 amounts, I want to figure out how much copper could we actually make. So this first step says, if aluminum was our limiting reagent, we could make ... So we're going to start with the 3 moles of aluminum, okay? So this part right here is given to us. We're going to take this number and we're going to plug it in right there, okay? Now, if we have moles of aluminum on the top, we need to put moles of aluminum on the bottom, just like we've been doing with these problems all year. So moles of Al, and we're trying to find how many moles of Cu I can make. So this part right here, the numbers come from the reaction equation. So we are looking at the coefficients. For every 2 moles of aluminum that react, so we're going to put 2 moles down here, we can make 3 moles of copper. So we're going to multiply across the top, divide by what's on the bottom, and you will be able to make 4.5 moles of Cu. So if aluminum is my limiting reagent, I would be able to make 4.5 moles of copper before all the aluminum runs out. So now we're going to do the same exact process for the copper 2 chloride. So it says, if copper chloride was our limiting reagent, we could make. So again, we're starting with 3 moles of CuCl2. Now these numbers won't always be the same, but they can be. So I have 3 moles CuCl2. So again, this part is given. And this part is going to come from my reaction equation. So for every 3 moles of copper chloride that react, so 3 moles of CuCl2, we are going to make 3 moles of Cu. So it's pulling from these numbers right here in these squares. So again, we multiply what's on top and divide by what's on the bottom. You can see moles of copper chloride on the top and the bottom, so they cancel each other out. And our answer here is going to be 3 moles of 3 moles of Cu is what is created. Now, looking at those 2 amounts, we have to decide which one of those 2 numbers is smaller. So my 3 moles of copper is my smaller amount. Okay, so because CuCl2 would make less copper, we determine that it is the limiting reagent. So my CuCl2 is my limiting reagent. And my aluminum up here is going to be my excess reagent. It's my extra. Now, the next question says, well, how much aluminum chloride will we make? So we're going to, again, use the limiting reagent to start. So we're going to start with our 3 moles of CuCl2. And we're going to look at our equation. So for every 3 moles of CuCl2 that react, how many moles of AlCl3 can be made? So I'm going to come up here, and we're going to see for every 3, we can make 2. That's what we're going to fill in right here. So 3 moles times 2 moles divided by 3 moles, we're going to find that you can make 2 moles of AlCl3. Now, our practice worksheet that we're going to do looks just like this, okay? So I'm going to walk you through this problem here, and then you are going to work on the packet and do the first 2 problems. See how far you can get using this as your guide. So it says, what if we were given grams to start? So instead of saying we have 3 moles of aluminum and 3 moles of copper chloride, it's telling me that I have 1 gram of aluminum and 5 grams of copper chloride. So my equation is already balanced. I'm given the correct amounts, okay? So I'm going to start. It says aluminum's molar mass. So if I look on a periodic table, I would see that aluminum has a molar mass of 26.98 grams. Now, copper chloride's molar mass, I need to look at my periodic table to see that copper has a mass of 63.55, plus I have 2 chlorines, which have a mass of 35.45. So when we type this into our calculator, we have 63.55 plus 2 times 35.45. So the total mass of copper 2 chloride would be 134.45 grams. Now, what you have to go through for this problem is take the number that's given, and that's going to go in this first box. So I have 1 gram of aluminum, okay? So this is my given. This next set where I have a gram to mole, okay? Those numbers are going to come from our periodic table. That's going to come from this area right here where I'm looking at molar masses. And last but not least, when I see my mole to mole, that's going to come from my reaction equation, okay? So that's going to be true for the one above and the one below for both parts of this. So to do the aluminum to start, okay, I have 26.98 grams of aluminum in each mole of aluminum. And according to my equation, for every 2 moles of aluminum that react, I can make 3 moles of copper. So take a second, do the math out. So again, you multiply any numbers on top and you divide by any numbers on the bottom. So I get 0.056 moles of copper. So if aluminum was my limiting reagent, that is how much copper I could make. So now we have to do this whole process again, starting with the copper chloride. So we take that 5 grams of copper chloride, and that's going to go in my first box here. So I have 5 grams of CuCl2. Now for 1 mole of CuCl2, I have 134.45 grams, so that's going to come down here. And now from my reaction equation, for every 3 moles of copper chloride that react, I make 3 moles of copper. So 3 moles gets me 3 moles. So again, we're going to multiply what's on top. So you have 5 times 1 divided by 134.45 times 3 divided by 3. And if copper chloride is my limiting reagent, I am going to make 0.037 moles of copper. So looking at those two amounts, okay, we're asking which one of those is the smaller number. So in that case, this is my smaller number, which means this right here is my limiting reagent. So down on the bottom of your paper, it asks you to label. So limiting reagent is going to be the CuCl2, because that is limiting how much of this we can make, okay? And then we're just going to copy this number over here. So we're going to make 0.037 moles of copper. Now, once you do that, that's the hard work, okay? This table down here is actually a little bit easier, because once we've already figured out what the limiting reagent is, these 4 boxes are just going to get copied into these spots right here, okay? So, because the copper chloride is determining how much copper we can make, the copper chloride is also going to determine how much aluminum chloride we can make. So if I have 5 grams of CuCl2, okay, 1 mole of CuCl2 is 134.45 grams, and 3 moles of CuCl2 react to make how many moles of aluminum chloride? So we go back up to my reaction equation, and we can see for every 3 moles of copper chloride, we're making 2 moles of aluminum chloride. So we're going to put a 2 up top. So we're going to math this out again. So I have 5 times 1 divided by 134.45 times 2 divided by 3, which tells me I'm going to make 0.025 moles of aluminum chloride. Okay? So that number just comes down here on this line. Now, last but not least, because moles are weird numbers, we don't love moles, we want to get those to grams. We want to make it something easier for us to understand. So how many grams of copper would that be? So we're going to take our numbers. If I'm going to make 0.037 moles of Cu, okay, moles of Cu on top, I'm going to put 1 mole of Cu on the bottom. And I'm going to look at my periodic table to determine copper has a mass of 63.55. And then we just multiply. So 0.037 times 63.55 tells me that 5 grams of copper chloride is going to give me 2.35 grams of copper. And I'm going to do the same thing for my aluminum chloride on the bottom. So I have 0.025 moles of AlCl3. So 1 mole of AlCl3 to grams of AlCl3. So that's going to be 133.33 grams. If you're like, Miss B, where did that number come from? Well, we take the mass of an aluminum plus the mass of 3 chlorines, and that is where that number comes from. So now we just multiply. So you do 0.025 times 133.33, and that gets you an answer of 3.33 grams of AlCl3. So I want you to use this as your guide, because the practice looks exactly like this paper. And if you use your sheet from last time, you've already balanced the equations and you've already found the masses of everything that you need. Email me with any questions.